here we go. We have another exam in front of us. This one is the 2016 practice exam. I don't know if this was the real exam they put out in 2016 and just labeled it as the practice exam on the College Board, but this is the 2016 practice exam. We will be going over this in its entirety, and hey, it is a cold, rainy day here in the Finger Lakes regions of New York, and it is October, mid-October, so it's a little colder today, a little bit of rain today. It's not snow yet. I'm happy about that. So what can we do? Grab a cup of coffee or hot chocolate, or some of you guys that are into those pumpkin spice lattes, and let's do some calculus. Let's do some mathematics. We're going to cover problems 1 through 10, multiple choice, in this video. And the calculator may not be used. But don't worry, that means the algebra is going to be simpler than if we needed a calculator. Okay? So let us begin. Good simple problem to get us going today. If y equals cosine of 2x, then dy dx equals. All right, let's start rolling right into this. All right? We have an inside, so we're going to use a chain rule. The derivative of cosine is negative sine. The chain rule tells me that the inside will stay the same. Then I multiply by the derivative of this inside, which is just 2. And we like to put our 2's out front. So I'll say negative 2 sine of 2x. And that is our answer, and that is choice A. Good, simple one to start. Number 2. I love these types of problems. Here's an equation, solve it, simplify it, do whatever. Here we need to integrate x squared times x cubed minus 1 raised to the 10th dx. I right away noticed something. I noticed that I have x cubed, and the derivative of x cubed is going to be 3x squared. So the derivative of something is there, if that makes sense. The derivative of x cubed is there. It's x squared. It's 3x squared. So that tells me I'm going to use u sub. That will make life easier. So u is going to be x cubed minus 1. du is 3x squared dx. Now, I only have, okay, highlighter, I only have x squared and dx. So I only want x squared dx, which means I need to get rid of that 3 on the right side. So let's multiply this by a third, so this goes bye-bye. And what I do to one side, I do to the other. So in for my x squared dx, I'm going to put in 1/3 du. All right? There are no bounds, so I don't have to convert my x bounds to u bounds. There's nothing in the top or bottom here, so there's no conversion for that. Okay, let's substitute in. The integration, again, x squared dx is going to go bye-bye, and in its place, I'm going to put 1/3 du. Any constant I always put on the outside. All right? Then in for x cubed minus 1, I'm just going to put u. Of course, let's not forget that's still raised to the 10th. All right? Much easier to integrate. Much easier. So, remember, integration is the reverse of the power rule in the reverse order. So I'm going to add 1 to my exponent, then divide by it. Okay? And, oh, by the way, this comes along for a ride. And don't forget, it's plus c. Okay? There are no boundaries, so I need to do plus c. The only thing I have left to do is to substitute whatever we took u out for back in. Meaning, u was x cubed minus 1. All right? Well, I need to put my x cubed minus 1 back in for u. So I have 1/3. Actually, instead of writing 1/3, why don't we just multiply our bottoms right now? 3 times 11 is 33. And the top, 1 times u to the 11th is still u to the 11th. In for u, is going to be x cubed plus 1 to the 11th. And oh, by the way, don't forget, I still have that plus c. That's going to be my answer there. So let's see. It's not A. That's silly. It's not B. What was it, B? Oh, look at this. This should be a minus. I wrote plus for some reason. Minus. That's x cubed minus 1 right there to the 11th. I wrote a plus there. Getting crazy in my old age. Okay, it's not B because there should be 33 in the bottom. Scroll down here. X squared is on the top. Here you go. Choice D in all of its glory. Looking at us like, you did the right thing. Number 3, find the limit as x goes to the infinity of the square root of 9x to the 4th plus 1 over 4x squared. Well, you should know that whenever I take the limit as anything goes to infinity, I only need to keep the biggest term on the top and the biggest term on the bottom. And then I simplify. If there's any x's left over after that, then I can put infinity in for that. So let's do this. The square root of 9x to the 4th, because that's the biggest term on the top, 4x squared. Let's do some algebra. The square root of 9 is 3. The square root of x to the 4th is x squared over 4x squared. Oh, nice. Cancel, cancel. It ends up being 3 over 4. That was simple. That was simple. Choice B. Number 4. If y equals x over x plus 1 all to the 5th, then find the derivative. I see two things right away. The first thing is I need to do the power rule. This 5 is going to come down out front, but the inside is going to stay the same. Then I need to multiply that times the derivative of the inside. Okay? So we have two things happening here. Let's go purple. So 5 comes down. This stays the same. X over x plus 1. My exponent goes down by 1. Times the derivative of the inside. Oh, low. D high, the derivative of high, minus high. D low, the derivative of below is this one. Draw a line and I square below. Okay, I've gone over this before. It is the low is the denominator, the high is the numerator. So it's low times d high, the derivative of the high, minus high times d low. I draw my line and I square below. It rhymes. Low d high minus high d low. Draw a line and square below. All my students know that, and they're all really good at this. Okay, so let's clean this up at this point. Okay, that's right. Looks like we're going to have to do some algebra. Well, this fraction here, okay, anything times 1 is itself. So I have x plus 1 minus, well, x times 1 is x. The x's are going to cancel. So I'm going to have 1 in the top in my numerator. So let's rewrite this whole thing now. So I have 5 times x to the 4th over x plus 1. Ooh, that 4th is on the outside, my bad. You know what, let's rewrite that. It's garbage. It's garbage the way I wrote that. X over x plus 1 to the 4th times 1 in the top, and in the bottom is still x plus 1. The whole thing is squared. All right? Well, here you go. Obviously, the denominator, it's making one fraction. So let's make one fraction here. All right? My rules of fractions with exponents mean this 4 gets applied to both the numerator and denominator. So I have 5 in the top, because that's really like 5 over 1. We have x to the 4th on top. On the bottom, I have x plus 1 to the 4th as well, because this 4 is distributed to the top and bottom, not multiplying, but the exponent to the power of 4 gets applied to both the top and bottom. And then we have times, we have 1, and then we have x plus 1 squared. All right. Well, if you know your rules with exponents, if you knew the rule here with a fraction, you should know what happens when I multiply the same bases with an exponent. I add the exponents, right? So I get x plus 1 to the 6th. And the top, if I multiply, is 5x to the 4th. I say this to my students all the time, that calculus is algebra heavy. You need to know your algebra rules. Knowing your rules for derivatives and integrals is obviously important, but that's not the only thing you need to brush up on your algebra skills. Your rules for exponents. Exponents are huge when it comes to derivatives and integrals, all right? But you can see this is just like algebra 1, algebra 2 type stuff that you need to rely on, okay? Again, you don't get a calculator for this problem. I mean, I don't know if you can even use one, whatever, but there it is, choice D. Number 5, water is flowing into a tank at a rate, okay, where R of T is measured in gallons per minute and T is measured in minutes. The tank contains 15 gallons of water at time 0. That is going to be important. Well, I'm assuming it's important, but let's see. Right? Values for R of T, for selected values of T, are given in the table above. Using a trapezoidal sum, oh boy. Okay, using a trapezoidal sum with 3 intervals indicated by the table, what is the approximation for the number of gallons of water in the tank at time t? Oh, I write this little graphic a million times, okay? Position, velocity, acceleration. They are one derivative away. I'm going to use D for derivative. But they're also, if I go backward, one integration away. And I get used to writing position, velocity, acceleration all the time. That's the same thing as first derivative for position, second derivative for velocity. Or yeah, I'll be okay. I'll be okay. It's the same thing as, okay, first of all, it's one integration away, one integration. This is the original equation, the first derivative, and the second derivative. I could put those in place for position, velocity, acceleration. I can also put in place my rate, my unit of measure, my rate, and then I guess my rate squared with to time squared. Okay, or the rate of the rate. Right now in the table, they give us a rate. We need to find the unit. They give us, all right, gallons per minute. We need to find gallons, okay? So we're going to integrate this. But we don't have an equation. That's why we need to use the trapezoidal sum. Okay? That's why we need to use the trapezoidal sum rule, okay? Trapezoid rule. Bam. Here we go. So what I'm going to do first is figure out my 3 subintervals they give me are. Let's go here, let's go here. Okay, from 0 to 4 is my first subinterval, subinterval 1. From 4 to 7 is my subinterval 2. And from 7 to 9 is my subinterval 3. I like to just create these rectangles so I can kind of see them as if they were the rectangles I'm creating under the curve, or in this case, trapezoids, all right? Now, the trapezoidal rule tells me, all right, trapezoidal rule, I take my width, or my height, whatever you want to call that, divide it by 2. I take my first y value, we'll call that y0, okay? And I add that to 2 times y1 plus 2 times y2, And then the last one, whatever it is, n, is here. I double all my values in between, but my bookends, what I start and end with, do not get doubled. Okay? Everything in the middle gets doubled. That's important to know. Now, when I look at these subintervals, I only have 2 values. For example, for this subinterval 1, from 0 to 4, I only have the bookends 9 and 6. So nothing's going to get, I don't have these. So nothing's going to get doubled. So I'm just going to have this and this. In fact, for every subinterval, that's all I have are the bookends. I have 6 and 4. And for this subinterval, okay, I only have 4 and 3. So when I set this up, you're going to notice there is nothing that's being doubled. So, subinterval 1. I'm going to do these like they're 3 separate things. My width is 4. That's my width here. So I take 4 over 2 times 9 plus 6. Okay, that's 2 times 15. That's 30 for subinterval 1. Subinterval 2. My width is 3 from 4 to 7. So it's 3 over 2 times 6 plus 4. Okay, so we got 24, well, was that 36? No, 15. I multiplied these, I need to add them. That's 10. Half of 10 is 2 times 3 is 15. That is 1.5 times 10 is 15. Okay, subinterval 3. Okay, this width is a width of 2. So it's 2 over 2. And I'm going to add 4 and 3. Add them, not multiply them. I almost wrote multiply. That's just 7. Okay? If I add all these up, okay, so that's 52. But here's the thing. Before this even started, before this process even started, at 0, there was already 15 gallons in here. Before I did this rate, and this rate. So I had 15 gallons in there before the 30, before the 15, and before the 7. So I need to add those 15. 67 gallons. 67 gallons. Choice C. A lot of explaining on that. And I really went back to explain in case, I mean, if you didn't know how to do this problem, you needed these explanations. Okay? The trapezoid rule is very, 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 very common on a final. You'll see that at least once or twice. Simpson's rule, I've never seen on a final. I don't know if your teacher even teaches you Simpson's rule. I like Simpson's rule because I like Homer Simpson. But the trapezoidal rule is where it's at. All right? And if you knew what you were doing without the explanation, this problem would have taken you probably 45 seconds. Okay? Number 6, the slope of the line tangent to the graph of y equals ln of 1 minus x at x equals -1 is. Okay, so what are they asking? Slope is the same thing as derivative. They're not saying equation of a line, the slope of the line. So I need the derivative of this at this point. Okay, at this point, okay, we're taking the derivative of this, y prime. All right? You should know your natural log rule for derivatives is 1 over whatever the inside is times the derivative of the inside, -1. So it's -1 over 1 minus x. Okay? Where do I want this? At x equals -1. -1 over 1 minus -1 is in for this x. -1 over this turns into a big plus. 1 plus 1. That's 2. After the explanation for last problem, it's nice to get a simple one here for this problem. Okay, -1/2, negative. That's choice B. Number 7. For which of the following pairs of functions, f and g, is the limit as x equals infinity of f of x over g of x infinite? Okay, in order for something to be infinite, we want infinity over some number, or infinity over something else that's infinite, but we want the top to grow faster than the bottom. Okay, this can still grow, and this can grow infinitely, but the top has to grow at a faster rate than the bottom does. Okay, so the bottom necessarily doesn't have to be a number, but the top has to grow faster. If the bottom grows faster, that approaches 0. Okay? If infinity is no longer there, then it's just whatever number you get. We had a problem. Let me look back here. I think it was number 3, where the x is simplified away, and we ended up with, was it 3/4? That was for problem number 3. And we didn't have infinity in there, so it ended up 3/4. Okay? We don't want that. Okay? We don't want infinity in the bottom because that's 0. Okay? We want the top to grow faster and faster than the bottom. All right, so let's take a look at these. The f of x is always going to be my numerator, and the g of x is always going to be my denominator. All right? So let's set that up. X squared plus 2x on top over x squared plus ln of x in the bottom. Anytime I go to infinity, I keep the biggest term in the top and bottom. These go bye-bye. X squared over x squared is 1. That's not infinity. It's not infinite. It's not A. B. 3x cubed is f of x, so that's on top, over x to the 4th. If I simplify that, okay, 3x's go bye-bye, 3x's go bye-bye, and I have 3 over x. I put infinity in. That does not go up forever to infinity. That approaches 0, not infinity. Ba-boom. Choice C. Okay, my f of x, 3 to the x in the top. My g of x, x cubed is in the bottom. I can't simplify that, so let's just put infinity in. Infinity cubed is still infinity. This will approach infinity. If you are unsure why that approaches infinity, start throwing in numbers for infinity starting at 1 and going up. Okay, the bottom, okay, is 1. Then it goes to 2, then it goes to 3, forever. The top is 3 to the power of 1, which is 3, okay? That would be a value of 3 overall value. Then we have 3 squared, which is 9. Okay, 9 over 2, that's 4.5. Okay, that's increasing. Okay, 3 cubed is 27 over 3. That's 9. That is going to keep on going up and up forever because the top is growing faster than the bottom. Anytime you have a base that's 1 or bigger, okay, it's not a decimal, I should say. Okay, and the exponent is infinity, that will grow faster than just the number infinity itself. This definitely does go to infinity. It is choice C. 8. 8 is a beautiful problem to not have a calculator. Tests you on a couple of different things. All right? The integration from 0 to 4 of the fraction x over the square root of x squared plus 9 dx. Please, please, please don't apply the square root to each one of these terms individually and say that's x plus 3. That is not a thing. Okay? There's a plus sign there. We can't just break them apart. All right? So what we're going to have to do is we're going to have to do u sub. Okay? Right now, I'm looking and I'm saying I see x squared. I know the derivative of x squared is 2x. Okay? So any constant I have is going to end up going on the outside. But I'm going to be able to get rid of that x because it's the derivative of x squared with my 2. Okay? It's 2x. All right? So the first thing I'm going to do, well, no, I'll do that last. Let's do the u subbing first. If u is x squared plus 9, du is 2x dx. But remember, we only have, where is the highlighter there? We have x and dx. So I want to keep x and dx. I want to get rid of that 2. So let's multiply this side by a half and this side. Okay, so now I have, get rid of that 2. Now I have the integration. I'm not touching the bounds yet. All right, these go bye-bye, and in place is 1/2 du. The top is 1, and I have the square root of u. Okay, now the bounds. These are currently x equals 4 and x equals 0. I want those u as well. So if x equals 4 and x equals 0, I'm going to use this expression, x squared plus 9. Okay? So if I put a 4 in for this x, 4 squared is 16. 16 plus 9 is 25. That is my new upper bound. It goes from 4 to 25. If I throw a 0 in for x here, 0 squared is 0 plus 9, that's 9. So my new lower bound goes from 0 to 9. You have to do that. You have to convert those bounds. I still don't like that square root. You should know the square root is the same as having an exponent, u to the 1/2. Okay? And I don't like the fraction, so I'm going to bring my u to the 1/2 up. But then I need to negate the exponent. All right? I need to negate the exponent. So I really have 1/2, the integration from 9 to 25 of u to the negative 1/2 du. Okay? When I said this problem tests you on several things, it tests you on u-substitution, tests you on converting your bounds, it tests you to see if you remember that a square root is the same thing as saying an exponent of 1/2. And I could have swore earlier, I said exponents are critical, okay? It also tests you on knowing that when you flip an exponent, you negate it, okay? A lot's going on here. Let's integrate this thing. It's the opposite of the power rule and the opposite order. First, I add 1 to the exponent. So my u has a negative 1/2, I'm going to add 1. That will be a positive 1/2. Then I divide by that exponent. Dividing by a fraction is the same thing as multiplying by the reciprocal. So multiply times 2, okay? Or 2 over 1, which is 2. Now, I want this from 25 to 9. And, oh, let's not forget, this whole thing still needs to be, I mean, this 1/2 is on the outside. I can't lose that. I still got to multiply it times 1/2. All right? Okay. This problem does not have a calculator, so it shouldn't be complicated to do, and it is not. Because we already know this is the same thing as saying the square root of u from 25 to 9. That's perfect. Those are two perfect squares. 1/2 times this monstrosity. Let's go. So we have 1/2 on the outside times 2 times the square root. We'll put our 25 in. Minus 2 times the square root of 9. Okay? This is 3. 2 times 3 is 6. This is 5. 2 times 5 is 10. I subtract them. That's 4. We still got to take half of that. We should end up with 2. That was a really good problem without a calculator to do. It was a really good problem. Number 9. Let f be the function with the derivative given by f prime of x equals negative 2x over 1 plus x squared, all squared in the bottom. Okay? And what interval is f decreasing? F decreases, the original f decreases when its derivative is negative. Okay? So they give us the derivative. I don't have to take the derivative of this fraction. This is the derivative. A fraction is only negative when you have a negative divided by a positive, or if you have a positive divided by a negative. This kind of tests your numeracy. Look at this numerator. This numerator, because it's squared, will always be positive. Always. I mean, the inside is squared as well. Okay? The bottom will never be negative. The bottom will always be positive. That means in order for this whole fraction to be negative, okay, we're only going to look at the top. That only happens when the top is negative. Okay? So I say, all right, let's find out where it's 0. I like using my number lines. And let's figure out on each side of the zeros if it's positive or negative, all right? Here's my x value. Here's the first derivative of x. Okay, so negative 2x equals 0. I'm finding my critical point, okay? Divide by negative 2, and that happens when x is 0. So right here at 0, my first derivative is 0. Let's try, we'll go orange. The number 1 and the number negative 1. I could pick 10, 5, 2, whatever, as long as I pick one number on each side of that critical value of 0. All right? Positive 1. What happens if I throw a positive 1 into this right here? Okay? I have negative 2 times 1. That means I get a negative 2. I get a negative numerator. I get a negative numerator. And remember, the bottom is always positive, right? So I get my negative over a positive. So this side, negative. Let's try throwing a negative 1 in. Okay, I get negative 2 times my x. Again, I'm going here, looking at the numerator. That's a positive 2. Okay, so I end up with this being positive. The bottom's always positive. A positive over a positive will always be positive. Initially, we wanted what? This way, from 0 to infinity. From 0 to infinity. Now, if it's a number, and I'm including that number, I do this, and infinity always has the parenthesis, never the hard bracket. Okay? So, the only one that goes from 0 to infinity, I don't even have to worry about hard brackets and soft parentheses, because this is the only one that goes 0 to infinity. That's it, choice A. Last problem, and let me tell you what, this is a layup. This is a layup. If you know, oh, we're going to do this in mint green. Yeah, mate. All right, I'm going to take the integral of e to the x plus e. All right? I hope you know the rule for the derivative of e to the x, because if you know the rule for the derivative of e to the x, you can go backward and integrate e to the x. The derivative of e to the x is e to the x. Okay? Derivative, d. If I want to integrate that, same thing. It's e to the x. So the integration of e to the x is e to the x. I have my plus. E is a number. E is approximately 2.718. It's like pi. It goes on forever. Let's just call it 3 for the sake of argument. What happens if I had a 3 here? Okay, what do I take the derivative of so that I get 3? Wouldn't it be 3x? I just go back, if I'm integrating, and add the x. So if that was a 3, that would say plus 3x. But it's not a 3. It's an e, isn't it? E is a constant. So I'm just going to say ex, like that. Okay? Are there bounds? There aren't. You should always put plus c. Okay? All of my answers have plus c. So even if you forgot, you would have lucked out. But it's e to the x plus e times x plus c. That was a great one to end on. That's choice E. And by the way, ring the bell, like the video. That helps me out. Follow me because, hey, I'm going to start putting up more videos. Okay, we're going to do problems 11 through 20 and so forth. We're going to do the short answer ones. And, you know, that's it. And a video or two ago, I mentioned Blink 182. We're doing the 1998 exam. And I said, by Enema of the State. There's another one called Take Off Your Pants and Jacket, and another one called, it's self-titled. They're great. So is Dude Ranch. Those are 4 albums. They're all good. They're great. Buy them. They just announced, I mean, literally after I said that, not even a week later, they just announced a world tour where they're going to be touring South America, US, Canada, and Europe. And this guy right here with 2 thumbs pointing at him, you can't see my thumbs, but they're pointing at me, got tickets to the Nashville show. Can't wait. Fate is smiling down on Visca the teacher. You gotta love it. Anyways, get their music. They're gonna come up with a new album. Tomorrow they got a single on October 14th coming out. Buy it. They're not giving me money. I just really like their band. But follow me and ring that bell so I can get some sort of money for some either advertising, or I can say like, buy the TI calculator, and TI can give me something. I would like to get some value out of this. But you know what? I get value if you learn something anyways. All right? Good luck on your work. Good luck in calculus. If you're preparing for an exam, good luck with your exam coming up. You got this, and keep on watching these videos. Bye-bye.